Hi, in this section we are going to talk about iterators. So why should we use iterators? First of all, the efficiency. Iterators are designed in a way that they work smoothly with memory safety features and they don't degrade the performance of our code. And also we can chain iterators together so we can have more complex but easy to read structures. And finally, we can turn many data structures like vectors and hash maps and other structures into iterators, which are very convenient to use. So iterators gives us a tool set that we can use in many situations which are safe to use and handles error in a Rust way. So let's start with iterators. Now let's see the definition of this iteration trait, and after seeing this I believe that it's going to be more clear. Here I'm going to say trait iterator, and inside this trait we have a type item and then we have a function. We are going to call this function next, and we have mutable self as the parameter, and we are returning an option here, and inside this option we have self item. So as you can see in this definition, we have an item type and we have a function here. In this function we are taking the self and we are returning the item optionally. So what we are going to have is either none or some. In our situation we were trying to compare the left side with the right side, and on the right side we had sum, and inside the sum we had the reference. So this is where this sum comes from this definition of the function. Now let's see how we can use this with a program that describes in a much better way. So I'm going to clean up this code here so it's easier for us to understand what's happening. And here I'm going to create a struct called Fibonacci. I will have current, which is U32, and also I will have next, which is U32. Then I will say implement iterator for Fibonacci. And here we are going to have type, and this type for us will be U32. After this type we are going to create the function we just saw. This function is next. Here I will say mute self, and we are going to return option, and inside this option we have self item. I'm going to create a current here, and for that I will say self.current. This self refers to this Fibonacci. Here we have this current and next. Here I will say self.current equals to self.next, self.next equals to current plus self.next. So this is the basic ideology of the Fibonacci. We are getting the current, and what we are doing is actually we are adding the value we have and the one after that, so we can have a sum. After this I'm going to say return sum current. Now let's try out this function. For that I'm going to say let's mute, let's say Fibonacci lowercase equals to Fibonacci uppercase, and inside this I have current as 0 and next as 1. Here I will create a for loop. Inside this loop I'm going to say println Fibonacci dot next dot unwrap, so that we wouldn't have an error here, and of course we should add this part. Okay, so we have our Fibonacci here and we are initializing it with the current 0 and the next one. And then we have our for loop. Inside this for loop we are printing out the values. So let's see if we were able to do this. So I'm going to say clear here, let's say cargo run. And this is our Fibonacci. 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 5 is 8. So that's another demonstration of how powerful iterators are and how we can use them. Now let's talk about the different type of the iterators. The first type we are going to talk about iter function. With this function we can borrow the values of a collection, so we don't modify the collection or consume it, we basically just read from the collection. Let's create a vector for it. Let's call it vec, and we are going to create our 1, 2, 3, 4, 5 vector here. Under this vector I'm going to say for item in vec.iter And inside this, I'm going to print out these values. I will say println, and let's put our item here. With this vec.iter, as we talk, we are getting the borrowed values, the references of these items. So we are not modifying this vector at all. So here I'm going to say cargo run. And as you can see, we have our values here. Now, what if we want to actually alter the values that we are getting? What if we want to modify the structure that we are working with? So let's say this is mutable and this is the loop we are having. Instead of vec.iter, I'm going to say vec.iter underscore mute. With this function, we can actually modify the values we are getting. Here we are getting a mutable reference for our value that we are borrowing. So we are not consuming the vector here. We are just getting the references which are mutable. So before printing out the item, I'm going to say item times equal to. So what I'm saying here actually is that with this, as we talked in many lessons before, I'm actually getting the value from the reference. So with this, here I'm actually getting the reference of the value, and using the asterisk here, I'm actually dereferencing it, so I'm getting the value out of the reference. Since I have my reference as item here because I said vec.iter underscore mute, with this function I'm getting the mutable references. I cannot modify the reference. I want to modify the value that this reference is pointing to. To get that value this reference is pointing to, I need to use this asterisk here with the item so I can get the value. And then here I'm actually saying I'm multiplying this variable, this value, and then I'm printing here. So let's see if it works out. Now we have 2, 4, 6, 8, and 10. As you can see, that way we are not only accessing the variables, but we are modifying it. If you notice, we have two different functions for mutable and immutable references that we are getting with this iter. This different classification actually creates a very safe way for Rust to work. And by doing this, we are just separating our actions, saying that I need to modify this, I don't need to modify this. It's not only important for Rust interpreter or compiler, it's also important for us as coders to think that how we are going to create our program. So it's not only beneficial for Rust, but it's also beneficial for us as coders. Now let's see our third type. Our third type is into iter. With this function, we are actually consuming the vector or the collection that we are working with. In the first two examples, we said that we are not consuming the vector. Here we are getting the references, but with this method we are actually consuming the vector, and we cannot use this vector after using it with our iterator. So let's see how it works. Instead of iter underscore mute, I'm going to say into iter here. I'm not getting the reference. I'm just going to print out the item and cargo run. Now we have our values, but it looks like the same, but if we actually need to use this vector again, let's say let my value equals vec.get, let's say 0. As you can see, we have an error and it says borrowed of mute value vec. As you can see, we consumed the vector here, so we cannot use later. It's beneficial if you want to use this just here, or you don't need to use this after anywhere here. You can consume the vector, but in most cases we don't want to consume the vector, and for that cases we had our first two examples. But this is the third example, third type of the iterator function that we can use with our collections, which the only one consumes the vector or the collection that we are working with. So that's our introduction for the iterators. Stay tuned for the next lesson where we're going to learn more about how to use iterators with different use cases. See you there.